To understand how function calls work in most modern programming languages, you need to understand what's known as the call stack, also known as the program stack or control stack, sometimes the runtime stack or machine stack. In general, the call stack is how the computer keeps track of the flow of control. You can think of it like a stack of plates or boxes, each of which is called a frame. Now each stack frame corresponds to one function call. And every time we call a new function, we bundle up all the information needed for that function, including the arguments and parameters, and even a pointer to the current line from the calling function so we know where to go back to when we're done. Then that new frame goes on top of the stack. Then any variables we create while running that function get stored in the top frame, the frame representing that function. So for example, when someone asks, what's the value of the variable x, we can look at the top box on the stack and see, is there an x defined in here? And if so, we can return its value. Then when we exit that function, we remove that frame from the stack and continue on with our code in the below frame. When our stack is empty, then our program is done. By way of example, consider the following code. So I have three functions defined. The first one is square of x, which takes in a value and just returns the square of that value. The next is sum of squares, which takes in two values, squares each one of them, and then returns the sum of those two values, so the sum of squares. Then we have a main function, which just initializes this process with specific values, so sum of squares with 3 and 4 here. So to walk through how the call stack is used while executing this code, when we run our code, we have what's known as the global frame, and this is where all the things that are not put into functions are stored. So for example, the names of these functions, since those aren't part of any other function, those would be stored in the global frame. So when we're in the global frame and we say call the main function, it knows what that main function is because we defined it and stored that definition in the global frame. So when we call this first function main, that says create a new stack frame to handle the execution of this function. Now in this case that has no parameters, so it's pretty easy to do. We just create a new block and we put it on top. Now while we're executing main, we call sum of squares with the values 3 and 4, which says create a new block, a new stack frame, and put that on top, one for the sum of squares. So now when we're executing the sum of squares, we have a variable called a, which has a value 3, and a variable called b, which has a value 4, and those are both housed within this sum of squares stack frame. So later on, when I say call square and pass in the value of a, it can look into that stack frame and say, okay, I'm going to call square with the value 3. Now when it calls square, it creates another stack frame, so that goes on top of the stack. And then we run through the body of square. And now here x has the value of what was passed in, which in this case is 3. So we're returning x times x. We say, what's the value of x? X has the value of 3 in this frame, so we'll say 3 times 3, and we'll return 9. 9 gets returned back to the previous frame, so we pop this frame, the square frame, off of our stack, and we're back in sum of squares right where we left. So it says take the 9, since this returned the value of 9, and assign it to the variable a2. Now this variable, a2, which has the value 9, is stored in the frame for sum of squares. And we do the same thing on the next line. It says call square b. So that creates a new frame. Notice a different instance of the frame for square. And it says store a variable called x with the value of whatever b had, which was 4. So we run through the body of square with x bound to the value 4. In this case, it says 4 times 4, it gives us 16, and it says return that. So we come back out to where we left, and it says b2 equals 16. So that b2 variable gets stored in the sum of squares frame, which is now at the top of our stack, since square has again left. Next, we take the final step from sum of squares, which says add a2 and b2. So look up those two values in the current frame, which we said were 9 and 16, sum them together so we get 25, and return that result. So that result goes back to where this frame was called. So we pop sum of squares off our stack. Notice we're back in main. That's the new top of our stack. And now we have the value 25. Now in this simple piece of code, we didn't do anything with that result. We could have perhaps printed it or used it somewhere, but we didn't. That value more or less just gets ignored. Main is done doing its work, so it gets popped off the stack, and we're back in global. There's nothing else to execute, so the code ends. So we can run this code, although it won't be very informative, because as we saw, it didn't actually do anything, but we can just, to make sure there's no errors, say python sos.py. Great, that's what we expected. Now let's deliberately cause an error. So I'm going to change one of these variables to a variable that doesn't exist. So x times y, the variable y doesn't exist in that function, so if we save and run our code, we should get an error. Now our code crashes, but the reason I wanted to do this intentionally is because when Python crashes, it tells you what the current stack looks like. So notice we got a name error. Our name y is not defined. That's what we expected. It tells us that happened on line 2 in the function square. It tells us where it is, puts an arrow to it, It's right there. Now our problem wasn't necessarily finding it, but sometimes it matters how this function was called to see what caused the error. So Python will tell you the entire stack of functions, so the current stack trace as it's called, that led to this current error. So if we just look up in this error, the line before that says our function square was called from line 5 in sum of squares. So there's the call for that. So line 5 sum of squares called square A. And we can see sum of squares was called in main. And main was called from just module, which is just the global space. So if our code crashes in Python and we have functions involved, it will tell us the trace of the current call stack. So all of the functions that currently have frames on that call stack. And that way we can backtrack to figure out what calls were made in order to get to the current point in our code. So every time a function is called, frames get added to the stack. The variables and parameters used within those functions get stored in that frame on the stack. And when that function is done, that frame gets removed from the stack, and all those variables and parameters disappear with it. As a result of using the call stack to keep track of our variables, so every time we create a function, all the variables for that function are contained just within that function stack frame. When we create a variable, it only exists within the region of code in which it's created. So if we create a variable within a function, we say that variable is local to that function. This region is known as the scope of the variable. So the scope is the section of code for which the variable name has meaning. So if I say x, if I'm within the scope of that variable when I say x, then I won't get an error. If I'm outside of the scope of that variable and I say the name x, then I get an error, typically a name error that says that name is not defined. So in Python, there are several different kinds of regions of a program which define scopes for variables. So there's the local scope, which is inside a function. So any variables created inside a function are local to that function. This counts for parameters as well. There's also a global scope, which is the top file level. So these are variables that are written into your files outside of any function. These are called global variables. So these are stuff that's right up against the margin. There's also built-in scope. So this is the stuff that's provided by Python, like the print statement and the value true. Now, there is some nesting at play when dealing with scopes. So if we define functions within our file, those functions are defined within the global scope. And the global scope we can say is defined within the built-in scope. So when you're inside a function, you're also inside the global and the built-in scope at the same time. So that way, inside our functions, we can still say the word print, and it still has meaning. There are some additional places that we can create scopes. For example, the modules that we import. So if we say the random module, for example, that defines a bunch of names of functions and variables. Those are all scoped to that module until we import them, and then they join our global scope. There are also objects or classes which will define scope, but we'll talk about that later in the course. Consider this code as an example. So this is valid Python code, although perhaps difficult to read outside of an IDE. Assuming this were just written into a file, and this is the top of the file, we have a variable, v1 equals 1, and that's defined outside of any function, so we call that a global variable. It's a variable that anywhere else in our code we can reference that name, and it will have meaning. We have a variable v2, which is defined as a parameter for this function, so we can see from the margin where the scope of that variable exists. It's only within this function. It starts existing when we run the function, it exists while we're in the body of the function, and when we return, that is, say when we exit the function, it stops existing. We take the value and we return, and that variable gets destroyed when its frame gets popped off the stack. Similarly, we have a variable called v3 here, and that's just created in the normal way, variable equals value. That's defined within a function though, so its scope is limited to just this function. It's also a local variable. And we have a variable v4, which is defined outside of any function, so again is considered global. So generally speaking, when you're creating a variable, you're going to create one of two kinds of variables, at least from the code we've seen so far. The variable you create will either be a local variable, that is, say if it's defined within a function, it's local to that function, or a global variable, which can be seen throughout the entire script. So every function creates its own local scope. That's the stack frame as we've seen it. So variables created within that function are then local to that function. You can think what happens in a function stays in a function. Parameters are considered local variables too, as we mentioned. So as an example, let me define a function here, def func1. We'll say a has the value of string, which says local, and then we'll print inside func1, a is, and I'll print the value of a. And then back out in the margin, we'll say func1, so we'll call our function, and then we'll print outside func1, a is, and then we'll print a. save and run our code. So we'll say python scope.py. And notice it printed out inside func1, a is local, so that's good. So this was okay. But then when we tried to run this one, it crashed. It said name a is not defined. So notice the variable a is defined within func1, so it's local to that function. It does not have meaning outside of that function. So this is an error. I could also define a second function, so something like def func2, and in that I could say print inside func2 a is, and then try to print the value of a. And let's call func2, so I'll say func2 and run our code. And we get a similar error, name error, a is not defined when we're inside func2. So we can still use the value of a from func1, but when we try using it from func2, it doesn't exist. So even though it's local to a function, it's local specifically to the function it was created. So we can't reference the value of a variable in one function from a different function. This is what's known as encapsulation. So the local scope for each function is separate from every other function. This means there's less likely to be conflicts between them, and it means when we're designing one function, we can do it without worrying about what the names of variables are in all of our other functions. So variables that are not local to a function are considered global. So these are variables that are created within the global scope. That is to say, any variable created outside of a function. So if I say x equals 3, but I do so up against the margin, then that variable exists all throughout my script. That means inside my functions I can reference these things. Now in Python, these are known as constants. When we define a global variable, if we attempt to use it inside a function, it is read-only. That is to say, we can only use its value, we can't change its value. If we attempt to change its value, we end up creating a new variable with the same name, which hides the global variable, which is a source of some frustrating errors for sure. So let's demonstrate this. So coming back to our scope example, let's create a global variable. I'll come up to the top here and I will say b equals global. And now let's see if we can use it. So I will say inside func1, b is, and then I'll print the value of b. This one was an error because local variables. And I will do the same thing here. So print inside func2, b is, and then b. And lastly, outside of any functions, we'll do the same thing. So print outside of functions, b is, and then b. Save our code, see if we can run it. And it doesn't crash. So there's no problems doing this. So inside func1, a is still a local variable that exists because that's where it was defined. So we can access a, we can also access b. We can print out b and its value is global. We can do the same thing inside func2 because it's just a different function, so why would it work in one and not the other? And we can also do that outside of any function because b is still just a regular variable in that regard. So note that the global scope includes both of the local function scopes. So we can print b no matter where we are in our code because it existed all throughout our code. Now, it's important to note though that this variable is read-only when we're inside a function. If we're outside the function, there's no problem. We can use it as we normally would, but if we take a global variable and try using it inside of a function, we can read the value as we've seen, but if we try to change the value, so if I said something like b is something else, what we're saying is b equals a value. That's how we define variables in Python. So that's saying define a local variable called b and give it the value something else. So now we have two scopes. In one of those scopes, we have a variable called b, and in the other scope, the global scope here, we have a variable called b. Now if we're inside func1 and we say what's the value of b, it will refer to this local scope. So it will say the value of b. But we didn't change the global variable. That still exists. It's just hidden because it has the same name. So when we ask what's the value of b, we find the local one first. So let's see what this does when we run it. So our code doesn't crash. Notice when we're inside func1 and we ask what's the value of b, it refers to this local variable b. If we're inside func2 though, or outside of any function, when we talk about b, we're still referring to the global b. So that's because this makes a new local variable which hides the global one. Say the global b. So there's a slight difference here between scope and what's known as visibility. These are two very similar concepts. Scope is where a variable name has meaning. So the variable name b has meaning throughout all of this code. The visibility is where we can actually reach that variable. So once we've put a local variable b here, the global variable is no longer visible within the rest of this function. This local variable b hides the global value. So the scope is where a variable has meaning. The visibility is where that variable can still be seen or used. This is useful for global variables. For example, for making constants, if you wanted to create a pi constant or something else, you can just define it once at the top of your code, and then everywhere throughout your code, you can just refer to that. My favorite color is blue. You can put that at the top, and then everywhere else through your code, you can just refer to favorite color. And then if your favorite color happens to change, you only have to change it in one place, and it will change everywhere throughout your code. Usually when you hear about global variables, particularly in introductory programming contexts, you'll be told to avoid them. Do not touch global variables whatsoever. They're a source of errors and all sorts of problems and headaches, which is generally true. Some languages will allow you to use global variables, which is to say non-constant global variables. The advantage here is that functions can have side effects. So instead of just input, process, output, it can also modify the values of global variables. And if those global variables change how your system works, for example, the location of a window on your screen or something like that, then the function can do that without having to return a value. It can just reach into the global variable and make that change. The problem is all of the functions can do that. And so all of the functions have to know which other functions are doing that in order to avoid making mistakes. It's a problem of too many cooks, you might say. If everyone can change these global variables, it's difficult to predict what those values are at a given point, and it just opens the door to a bunch of new errors. Particularly, this is a problem if you have multiple programmers working on one big project. Now everyone in that project needs to know how everyone else is using those global variables in order to avoid using them incorrectly. So it's a good idea to avoid global variables, except in very certain circumstances where you know it's not a problem. Using global constants, however, not generally a problem. Each individual function is only ever reading the value, so they're not interacting in ways that could disrupt other functions. For completeness, I'll show you how to use global variables, that is, say, non-constant global variables within your functions. I'll make a new one here. So I'll say C equals also global. So it's a string with the value also global. And I will come down here and I'll say print inside func1, C is C. Inside func2, C is C. And I can just take this one and change the values. Okay. So this is the exact same thing. We have a global variable, or a global constant, I should say. So it has the value also global, and we'll come into our function 1 here and make a local variable that hides it. So I'll say C equals just some sort of garbage text. Now just to run our code so that everyone's on the same page here. This is doing the same thing as we saw before. We're creating a global constant, and then we're creating a local variable, which is going to hide that global constant. So if we're in F1, or func1, it's going to print out the local value, but everywhere else, it still has its global value. So we have two separate variables in our system, stored in two separate stack frames with different values. Now, if we want to have one value, that is to say, if we're in func1, and we want to say, when I say C equals I want to change the value of this global variable, then we have to first tell Python, I know what I'm doing, I mean to do it this way, please let me do it. So you say global C, which declares this variable C as being a global variable. So it says, talk about this variable that is already global out here, and now every time I say C, it will mention the global variable C. So we save this and run our code. What this should do is change the value of the global variable. So it will not only print out different here, but it will also be changed everywhere else it's used. Save and run our code. And now notice C is changed everywhere that it's used. So we could say this is a global constant, but this makes C a global variable. Constant meaning unchangeable, variable meaning changeable. Let's make sure we understood all that using a comprehension question here. So what is the output of this syntactically valid but semantically confusing code? So let's pull up a variable table and we'll keep track. So starting from the top, code defines F1. That's great. Moves on to the next line, which says define F2. Okay, so now we know what those both mean. And it comes down to the first line in the global space and says a equals 1. So it creates a global variable called a with the value 1. Now, because we have different functions, and notice we have the same name in f1 as in f2, let's create separate scopes in our variable table. We have separate boxes containing these things, so let's keep them separated in our table as well. So I'll say in the global space, we have a variable called a that has the value 1. Then it goes on to the next line. It says call f1 and pass in the value of a. So if a is 1, we call f1 and we create a variable called x that now has the value 1. So that creates a new scope, so we'll call this scope f1. And in that scope, we have x with the value 1. Now the next line says x equals x times 10. So we say take the value of x, which is 1, multiply it by 10, which is 10, and store that back in x. So x now has the value 10. And that's the end of that function. So it says go back to where we came from and then print the value of a. So output is irrespective of scope, so we just have one general output section. And here we print the current value of a, which, since we're in our global scope, when we say the variable a, that means refer to our global frame here, which says a has the value of 1. So we print out the value 1. The next line says print the value that's returned by f2 at a. So we call f2 of a, and whatever that gives us back, we'll print it out. So we have to run it first. So we go f2 of a, which comes up here and says create a variable called x and give it the value of what's in a. So a, when we're talking about it in the global space, has the value 1. So let's create a new scope for our new function. We'll say f2, which has a variable called x, which has the value 1. So now x has the value 1, and it says call f of 1 with x plus 1. So if x is 1, we will say f of 1 with the value of 2. Now notice we've already finished this whole scope. We could have just deleted it since the function doesn't exist. For our variable table, let's keep track of everything. What I'll do though, since we're creating a second instance of this function, is I'll create a second instance of its scope. So we have a new value for f1, which now has a new instance of this variable x, which starts with the value, in this case, 2, because that's what was passed in with x plus 1. So running through the body of f1, we say the value of x, which is 2, multiplied by 10 gives us 20, and store that back in x. So we put 20 here. And now again, this function doesn't say do anything with that, so that's done. And we return back to f2. Now f2 says return the value of x. But if we're in f2, so that's this scope here, the value of x hasn't changed. It's still 1. Notice we had a different instance of the variable x, so we had two different copies of the same name, but because they're stored in different scopes, there's not really, at least as far as the computer is concerned, there's no confusion about which one we're referring to. So if I say x while I'm in f2, I talk about the local variable x that's defined in f2, which has the value 1. So we return the value 1, and we print that out. And that's the end of that code. So a few interesting things to note here. The value of a variable that's passed into a function is a copy of that variable. So when I'm passing a into a function, I'm saying take the value 1 and clone it into this variable called x. And when I say pass the value of a into f2, I'm taking the value 1 and cloning it into the variable x. When I say x plus 1 here, I'm not changing the value of x. I'm saying take the x value, which is 1, add to it, and pass that 2 into this other function without changing the existing function value. And as we described, separate functions will have separate scopes. So if you have the same name defined in two different scopes, that's not a problem for Python. It can keep track of which one it's currently using and reference it correctly. So the x in f1 is different from the x in f2. Each one is local to their own functions. Notice also when we changed the value of x in f1, it didn't have an effect outside of that function because that was again local to the function. If we want to have the values in our functions have impact outside of that function, so elsewhere in our code, then we need to return that value so we can use it elsewhere in our code. Let's do another comprehension problem here, this one involving some global variables. So we'll bring back our variable table. Now walking through this code starts with c equals 0, so out in the global scope, we have a variable called c that has the value 0. And it defines a function called f, it defines a function called g, it defines a function called h. If you want, you could technically put those in here. You could say f, g, and h, and these are represented by some function. It's not going to help too much, but this is how Python sees it. It takes these names as well as sort of variables, and the thing they're bound to is, rather than a number, it's an operation. But That makes our table sort of confusing, so let's not do that. So we defined 3 functions, and now we're down on the next line in the global scope, which says call the function h. Now h doesn't take any parameters, so we just create a new scope for h, and we jump to the body. So we're here, it says for I in range 2, 10, 2. So what we should do here is figure out what is that range. So I'll just put this range value here. We have a range which starts at 2, so its first value will be 2. It ends at 10 and it goes up by 2. So if its first value is 2, the next one will be 4, then 6, then 8. And notice it doesn't include its last value, so it's just 2, 4, 6, 8. And now the variable I will get a value from that range every time. So in our h scope, we'll say I has the value from the range of 2. Now with I equals 2, it says call f of 2. So pass a 2 in here. We create a new scope for f and a variable x. So we say f. I'm going to put brackets here so we know that these are functions and not variables, given my limited naming capacity. So we have a function f here, which has a variable called x, which has the value of I, so 2. Now, f of x says global c, which means referring to this variable c, we say c plus equals x. So take the value of x, take the value of c, add them together, so 0 plus 2, and store that back in c. So now our global variable c goes up by 2. Now our function f is done. We return back to our calling function, which was h. The next line says call g with the current value of I. I is still 2 when we're in h. So we call g of I, g of 2. Come up here, we create a new scope for g and its variable x. So new scope for g, it has a variable x, a parameter called x, and it gets its argument value, so in this case 2. That says c equals x. Notice it didn't say global c, so this is creating a local variable c that has the value of x. So inside this scope we say c, and we give it the same value. And then it says print c. This is our first print statement. So we'll have an output section. Again, all the outputs are non-local. There's just one output section. So any output that happens is to the user. It's not inside a scope anywhere. So we print out the value of c, which is 2. That's the end of our g function. So we come back to where it was called from, which is inside this loop. So we go back up, and I gets the next value from a loop. So our range was at 2. We go to 4. All right. So these are both done. So we could technically delete these if it keeps our variable table a bit simpler to understand. Right? So the function f, as soon as it was done, could have been deleted, and the function g, now that it's done as well, can also be deleted. It doesn't keep those scopes. Those variables disappear as soon as that function is done. Notice the changes to the variable c persist, though, because that was a global variable. So I gets the next value, which is 4, and then we call f of 4. So we create a new scope for 4. I'll call this f prime, just so we can distinguish if you're keeping track of both of them. And the variable x, the parameter x, I should say, gets the value of I, which is 4. Then our f function again says take the global variable c and add the value of x to it. So our global variable c up here is now 6. And the second call to f is now done, so we can get rid of all that information, and we're back to where we were. We go to the next line, which says call g of I, where I has the value 4, so we create a new scope for g. G has a parameter called x, and the argument we gave it was a 4. Again, g says create a local variable called c and give it the value of x, so again 4. And then we print the current value of c, so again we print a 4. I feel like this is getting pretty repetitive, but let's continue on. G finishes, we go back to h. H goes to the top, we get the next value from our range, we say 6, and that does the same sort of thing. So we call f with 6, so f double prime has a variable called x with the value 6. And that says c plus equals x, so 6 plus equals 6 is 12. And f is done, so all this pops off the call stack. We end up back where we called it, and on to the next line we say g. So we call g, it creates a parameter called x that takes in the value of I, which is 6. It says create a new local variable called c and give it the same value. And then print that value, so 6. Now that function's done, so it pops off the stack. All that information disappears, and we're back here. We go back to the top of our loop, we get the last value from our range, so I is now 8. And we do this work one more time. So we say f triple prime, which creates a variable called x, which has the current value of I, which is 8. That says go to the global C and add the current value of x to it. So 12 plus 8 gives us 20. And then f is done. We go on to the next line, which says call g for the 4th time. Create a parameter that has the value 8, and then create a new local variable called c that also has the value of whatever's in x, which is also 8. And then print that out as well, 248. And now g is done, so we can get rid of its frame. And now we're at the end of the h loop here. So we go back up, there's no more values in the range, so h is done. So we can, if we want, delete all of this as well, because h is done. We've returned to the end of this line. We go on to the next line, it says print c. We print the current value of c, which is global, since we're in the global space asking what's the value of c, and it prints out the value of the global c. And that's it. That's the idea behind global variables. They're defined outside of any function. If you use them within a function, they're constant. If you want to, and again, I highly recommend you only do this when you absolutely have a valid reason to, but if you want to make global variables as opposed to global constants, you can declare them using the global keyword in Python. And then when you use them, they will modify the global variable instead of referencing a local variable.